Hey guys, how's it going? So with this video, we're going to be moving on from talking about the reaction trends of alkenes. Over the past few videos, we've been talking about how the double bonds react, and we've also been learning a lot about regioselectivity, like Markovnikov's rule. But in this video, we're going to start expanding our knowledge about how functional groups react with learning about how alkynes react, which are triple bonds. When we were looking at the reaction trends of alkenes, the majority of the reactions centered around the pi bond, which was formed from the unhybridized p orbital from both the double bond carbons. Now, the reaction trends of alkynes is very similar, but instead of one unhybridized p orbital, each triple bond carbon will have two unhybridized p orbitals. We classify this as the carbon being sp hybridized. The geometry would be linear once the triple bond is formed, and each triple bond carbon has two unhybridized p orbitals that will both be used in forming a pi bond. So that triple bond functional group actually has two pi bonds instead of the one that we saw with double bonds. The fact that alkynes have two pi bonds makes a huge impact on the reactions. So if we have 2 moles of the reactant, each of those pi bonds can react, where the alkene can only act once because of its singular pi bond. The alkyne can act twice. So here in this general scheme of the trends of alkynes, we can see an alkyne go to an alkene and then be saturated again to form an alkane. But it is dependent on how much substrate we have. A good first reaction to look at is the hydrohalogenation of alkynes. This is going to happen very similar to how we did this reaction with alkenes. The regioselectivity is going to be Markovnikov, and if applicable, we're going to have a racemic mixture. The difference comes in the amount of hydrogen halide we have. If we only have 1 mole, we're going to get the haloalkene. If we have 2 moles of the hydrogen halide, we're going to fully saturate the alkyne to form a dihaloalkane. One way to think about this is that we're going to do the first hydrogen halide reaction with the alkyne to form the alkene. And if we have another mole of hydrogen halide to react, the pi bond that's now on that haloalkene is going to react with the next mole of hydrogen halide to form our dihaloalkane. So essentially, it's what we did before, just doubled. If we take a deeper dive into the details of this reaction, we see that it's super similar to what we've seen before. We're also going to have that carbocation intermediate. But since this reaction happens twice, we're going to have 2 different types of carbocation intermediates. The intermediate from alkyne to haloalkene is going to give us a vinyl carbocation. This is just a carbocation that the carbon that has the positive charge is also contributing in a double bond. Then, when we go from a haloalkene into a dihaloalkane, we're going to have that typical carbocation that we saw before. And everything else is super similar. Another really good reaction to build the similarities between the reactions of alkynes and alkenes is halogenation. When we have 2 moles of the halogen, we can go from an alkyne to a tetrahaloalkane. This is because with just 1 mole, we will form a dihaloalkene that still has that pi bond that can react again with an extra mole of halogen. If you're more interested in the reaction and the actual mechanism of this reaction, a lot like that of hydrohalogenation, both of these reactions perform just like how we analyzed with alkenes. Just if we have 2 moles of the reactant, we're going to have 2 different intermediates. In the case of halogenation, we have that same halogen intermediate. In this case, our first one just has a double bond. So if we have 2 moles of the halogen, we can go all the way from an alkyne to a tetrahaloalkane. So sometimes it's really important, definitely on exams, to pay attention to the amount of moles of reactant they put for an alkyne reaction question. Even though alkyne reactions are very similar to alkene reactions, there are some key differences. Throughout this video, I wanted to just show hydrohalogenation and halogenation, the 2 main reactions that are as similar with alkenes than they are with alkynes. But moving forward, we're going to start seeing bigger differences. On top of that, there's new types of reactions we can consider with alkynes that we couldn't consider with alkenes, such as really good reactions that we can use for carbon extension for retrosynthesis, and the fact that terminal alkynes, that hydrogen is slightly acidic. So we're going to dive into more of these topics with future videos. I just wanted to use this video as a really good introduction to our next functional group. I hope this video was helpful, and I hope you guys have a great day.